Okay, so hello everyone to my talk regarding observability-driven automation and going beyond GitOps with Keptn. As you might have noticed, this is an English spoken talk. But if you have some problems or if you don't understand something, just feel free to ask me in German. I'm speaking perfectly Austrian German, so I think we'll make this together. My name is Thomas Schütz. I'm a principal engineer for Dynatrace, mainly responsible for cloud native stuff. And I'm maintainer of the Keptn project. Furthermore, I'm tech lead of the CNCF tech delivery. I'm lecturer for cloud native stuff and also CDF ambassador. Yes, in my previous life, so before I went to the cloud native space, I was a systems engineer. And during this time as a systems engineer, I often deployed software or made configuration changes on Thursday in the mid of the night. Whoever deployed something on Thursday in the night? Okay. Some people raised their hand. And most of the time I thought, yes, after I deployed everything, I tested something, and for me and the developers, everything worked perfectly fine. So, party, let's go for a beer, everything fine. But at some point in time, the next day in the morning arose. So I had to do a lot of phone calls. Lots of people complained that applications run terribly slow. And yes, we had the pressure to fix bugs. And sometimes this was not really funny. So why did we get to this problem? So at first we made our tests manually. So this was some years ago. And sometimes the monitoring was not proper. So let's say all of the metrics we had for our application were perfectly green. So everything was running. But in the end, our customer tried to access the application, and the application was terribly slow. So not really the funniest situation. So for leaders, this leads to this conclusion. So one does not simply deploy on Thursday evenings or on Fridays. So which options do we have? We can deploy between Monday and Wednesday, but will this help us? I don't think so. So in the last few years, we got to a point where we have new options to solve these problems. So we have cloud native stuff. So just as a start, should we wait until Wednesday for security updates? I don't think so. The second thing, if we wait for deployments, and if we say that we don't want to deploy in time, what about the well-praised dev prod parity, which we know from the 12-factor app? But we are in a cloud-native world, so everything is better. So at first we have Kubernetes. I think this solves all of the problems we had in the last 20 years, right? And using GitOps, our deployments are stable. So everything we have in our Git repository gets reflected on our Kubernetes cluster. So last but not least, our customers can expect that the application is running flawless, right? So I don't think so. And this is what this talk is about. So at first, we will take a look on what is GitOps and where the problems with GitOps are from my perspective. Furthermore, I will tell you some things about metrics, about service level objectives, service level indicators, and so on. I will tell you something about Keptn. So I think you see the Keptn logo. So yes, it's a bit about this. And how we can go beyond GitOps with Keptn. So how can we extend GitOps and making everything better? And last but not least, we will wrap up this, and I will tell you how you can contribute to Keptn or how you can get into the community. So, at first, what is GitOps? Let's say 1 year ago, I thought GitOps is pretty easy. So I take my configuration, check this into my repository, have my CI pipeline, and this gets applied automatically at every time I checked in. But in fact, this is not GitOps. There is a GitOps working group, and they specified some characteristics of GitOps, and I will make this clear a bit. So at first, we assume that all of the configuration we have in our Git repository is stored declarative in a versioned and immutable way in the Git repository. Furthermore, this configuration is pulled automatically. So we might have some GitOps controllers like Argo CD, like Flux, and however they are called, which are there to watch Git repositories and find out what's new there. And they compare exactly this state we have in the configuration with a state which is stored on the target environment. So in my case, this is mostly Kubernetes, but there might be other environments where this could be applied. Okay, so after we apply something with GitOps, we know a few things. So for instance, our technically desired state is met. So if we have some Kubernetes deployments and we specified that we want a certain amount of replicas, that we want to have some environment variables configured, and so on, we can assume that after this manifest is applied, that this state is met. Furthermore, by working with health checks on Kubernetes clusters, we know that they are okay. So we know that if you have some HTTP endpoint you query with your health check, that this might be perfectly fine. But when we are dealing with GitOps, we don't know if our infrastructure was ready for this deployment. So when we're using GitOps controllers, the GitOps controller compare the state of the Git repository with the target infrastructure and try to get to this state. And they don't ask you in the most cases. So at this moment, when you start, when the configuration drift happened, the GitOps controller wants to get to this state, but it doesn't take care about if the infrastructure was ready for the deployment. So for instance, you could have an update on the Kubernetes cluster going on, and so on. And we also don't know if how risky it was to deploy our application. So it might have been that we had around 20 downtimes in the last 24 hours. Hopefully not. But this should also be taken into consideration before deploying something. And last but not least, we know, as I said before, that our technically desired state is met. But we don't know if our application is really running. So for instance, it might be that the technically desired state is okay, but I don't know how my customer feels with this application. So I don't know if it takes him about 30 hours to get, 30 seconds to get a response to his request. Often I don't know if he gets some errors when he starts something. So, yes, we might miss something in our GitOps scenario. For instance, we might need some things as pre-deployment checks, like risk assessment. So, in which state is my infrastructure? How are my error budgets, and so on. We want to take control over the GitOps process, which might work in some GitOps tools like Argo CD. And we want to do staging automatically. So we want to get from one stage to another, which is also often not possible via pure GitOps approaches. Last but not least, we also want to do post-deployment checks. And I heard a very interesting talk, I think 2 hours ago, about smoke testing, performance testing, and so on after deployment. So we want to do tests automatically after each deployment. And last but not least, we want to know how our application is behaving and want to have some kind of application health checks. And last but not least, and I know all of the open source enthusiasts are very security fan, so we want to do automatic security and vulnerability checks. So, and as I told you before, I'm from Dynatrace, sorry, and Dynatrace is an observability company. And Dynatrace is also the company which is behind Keptn, so we are working on Keptn as an open source project. We donated Keptn to the CNCF, and it stays an open project. But yes, we as Dynatrace or as observability provider have a lot of data, and data can help us making decisions. For instance, all of the metrics we are collecting with our tools such as Dynatrace, Prometheus, Datadog, I think Nagios, and however they are called, yes, they are measured by monitoring solutions. And from this, we can derive service level indicators. For instance, to find out how the system is behaving at the moment and which behavior the customer is experiencing. This could be such things as the response time, such as the error rate, such as critical security problems, the average memory, the average CPU, so everything we know from our monitoring systems. Furthermore, from these service level indicators and metrics, we can derive service level objectives and error budgets. So for instance, we could say we want that our response time in 90% of the cases is below 500 milliseconds. We want to know no errors on. We want to have no errors on our application, and before we want to deploy something, we want to make sure that we have enough error budget left to if something breaks. And based on these things, we can take decisions. So we could say, if we deployed something to our development environment and tested something and have an error rate of 0, or the response time is perfectly fine and everything is shiny, we could promote to the next stage. Furthermore, we could also say, yes, our error rate got higher than 0, so we do an automatic rollback. Or if our error budget is below our threshold, then we simply do not deploy. So exactly with this data, we can take decisions. And the platforms we have, such as Prometheus, Dynatrace, and so on, can provide us additional data to make this a bit clearer. So what is Keptn? So in the mid of Keptn, we always are operating on service level objectives. So there is a number, so such as 98 as stated here. And these describe the business desired state of our cloud native apps and infrastructure for every stage. So such as a dev environment, staging environment, and a production environment. And Keptn is triggered based on events. So it might be that you want to deploy something, so you fire a deploy event. You want to evaluate something, you fire an evaluate event, and the same for tests. And Keptn can orchestrate exactly this. So at first, we assess how the system is behaving at the moment. We can deploy something, can test something. in the end evaluate something and promote to the next stage, and there everything starts at the beginning. The same is for day 1 and day 2 operations. So we might have a monitoring solution which could also interact with Keptn. And Keptn has a lot of tools which it can, a lot of tools can integrate into Keptn, such as Jenkins, Azure DevOps, such as, what do we have here, Litmus K6, and so on. So there are many integrations out there which can be integrated in Keptn, and all of them get orchestrated through cloud events, and this is also an open standard. So I told you that Keptn uses service-level objectives to evaluate app and application infrastructure desired state. So how does this look like? So at first, we want to start some kind of evaluation. Then we have an evaluation service in our Keptn infrastructure. This is called the Lighthouse service. You don't have to remember this. And we have defined some SLOs. So for instance, we have objectives. They are based on the SLI error rate in my case. And the criteria is that the error rate has to be lower or equal 1 in this case. The same for JVM memory, which is not monitored in this, which is not evaluated in this case, and so on. And based on these SLOs, we try to calculate a total score. So every SLI we have in the SLO gets part of a score. And we can say, if our total score is higher than 90%, then we pass and go forward. Or if we are higher between 75% and 90%, we raise a warning. And below that, everything fails. And on the second, and we get these SLIs from our monitoring provider. As shown here, this might be Prometheus, this might be Dynatrace, Datadog, I think also Splunk, and so on. And in the end, SLIs are also specified in a more or less declarative way in Keptn, which show you where you see the, how the error rate is fetched, and yes, and so on. Good. So how does this look? How does the calculation look like in reality? So we have service level indicators, and this can be some things as the response time in 95%, such as the overall failure rate, test steps, and so on. And we have the SLOs for them. In the first step, so at our first deployment, this is the base data, we define that our response time in 95% of the request should not be lower than 100 milliseconds in this case. We also define that that the overall failure rate should not be lower than should be lower than 2%. And one more interesting thing is the test step login response time, where we say it should be lower than 150 milliseconds, and it should be less than 10% slower than before. So than the last evaluation. And yes, this is the target value of our SLO overall score goal. So we assume that if we get 90% of everything, then it's okay. If we have 75%, this is a warning. And we can use exactly this information to also take actions. So for instance, if we are above 90%, we could say, yes, everything fine, deploy to the next stage. Or if we are in a blue-green deployment, just switch the traffic to the new deployment. But if you are between 75% and 90%, I need to get an approval. So do a manual approval if you are in this stage, or write a Slack notification, or whatever. So then we are building we are deploying the first thing, and we see, yes, everything is green, everything perfect, and yes, we have an overall score goal of 100%. At our second build, we see that the response time got higher than 100 milliseconds, so 120 milliseconds, so it gets to a warning state. The same for the failure rate, and we saw that the test step service calls are higher than before. So we see that our overall score goes below this 75% and it fails. And in the third case, we saw that our response time raised higher than 10% in comparison to the last one. And we had one critical security vulnerabilities, so we also fell below the 75%, and this was also not okay. And last but not least, this got corrected in the last build, so everything is fine here and, again, and yes, we can go forward. Okay, so I started to talk about GitOps before, and using this information we have now is we could go beyond GitOps with Keptn. So let's say we have our GitOps in place. We know that everything is continuously reconciled, that everything is running perfectly fine. And now we take Keptn into the equation and want to extend this with observability and application health checks and an SLO-driven control flow. So we can use our observability provider, Prometheus Dynatrace, to observe our Kubernetes environment. Then we use Keptn to get data from these observability providers and to evaluate the state of these environments. And we could also use our observability provider to notify Keptn that something is not really okay. So for Prometheus, you can raise alert manager event notifications to notify Keptn and so on, and trigger events with this. And Keptn can be used to control the Argo CD process or the Flux process and to promote to the next stage. Because if we are in a GitOps environment, we cannot simply say we roll back our environment or we trigger another thing in our Kubernetes, cluster. We always have to go back to the Git repository and change something to get this in sync. Okay, so I think I talked very much, so let's go to kind of a demonstration. Where is it? There is it. Okay, so in my case, I have a simple application which is deployed with Argo CD. This application is the potato head, and what I want to do, or what I want to demonstrate now is I want to change something in my Git repository. This will trigger Keptn. Keptn will do some evaluations afterwards, and in the end, hopefully our application will be working. So these are my manifests for this application, and what we see here is that I have deployed a Helm chart with the target revision of 0.11 and so on. And I think this application is stable enough now to get this to a higher version. So let's say this is the application 0.20 now. And what we see in Argo CD at the moment is that the version 0.11 is deployed. And we could also take a look on this application at the moment and see that exactly this version is deployed at the moment. Okay, so I changed the target revision here, and now I will simply commit this change. So normally I would create a branch, would do the changes, would raise a pull request, someone would approve it, and hopefully, and then the process would start. But as we don't have so much time now and I have no approver here, let's do it directly. So I committed the change now, and in a few seconds or after I refresh this, I should see that Keptn okay. Did I change this? Yes. So the demo code doesn't like me today. So now it got out of sync. So we see that Keptn has been notified that something happened with this deployment. So what you see here is the Keptn bridge. So this is kind of a graphical representation of what is happening in Keptn. And what we could do, what I simulated here, was that I tried to get the error budget, and yes, pre-deployment checks were already perfectly fine. And we said yes, we could deploy exactly this version now. So we see that we have a version 0.2.0 on in the queue, and now we could say yes, I want to get this to my system. And this is more or less a speciality of Argo CD, because I could hook into the sync process. So for instance, or in this configuration I said there is no auto sync. If you get out of sync, notify Keptn, and Keptn will tell you if you can sync. So I will sync now, and what I will see in Argo now, this is the application I talked about. Hopefully this will start to sync now, yes. So I see that my application syncs now and that it got synced. And everything you see here gets done in Keptn. So what you could also do during this, you could also include such a deliver infrastructure step before deploying something, or check something before you're delivering this. And this deliver step here was the update to Argo CD. So we notified the Argo API that we want to deploy now, and this got deployed afterwards. What we are doing now is we are running tests. So in my case, I added a K6 test step, which is running now automatically. And this is also a thing I like to do very much combined with blue-green deployment. So for instance, you could deploy something, could run some tests, could evaluate something, and if everything is running fine, just switch to the other version. These tests will take about 30 seconds, I think. In the end, you see that the K6 tests were running perfect. And now Keptn talks to the observability provider, tries to find out, gets the metrics, finds out if everything behaved as it should, and in the end, yes, hopefully we'll get an okay. So, what did we do in the meanwhile, or what happened behind the scenes? Before I started this demonstration, I set up an Argo application and created a Keptn project and service, obviously, because otherwise this would not have worked. Furthermore, I set up the necessary notifications in Argo, so Argo notifies Keptn via notifications. And I also set up a webhook for Keptn, so this is kind of a ping pong. Argo notifies Keptn, Keptn notifies Argo, and so on. And last but not least, I labeled Argo applications with Keptn information. So this was also the thing you saw before, that Keptn knows under which URL this is, the application is reachable now. So let's get back to the demonstration. That's a bit strange now. Oh, that's working. So, is this still running? This might take until around 2 minutes. So let's get back to the last evaluation. So what we see in our evaluation here in Keptn is that we have some kind of a history or heat map of our deployments, or of the quality of our deployments. For instance, we see the total score so we see if the state of the score before. So we saw except one application, everything was okay. Except one deployment, everything was okay. We also see that the error rate was and the response times were already okay. This is not the best for the demo use cases. But we also see some more data here. So we see an SLI breakdown where we see the response time of 50% of the services of the requests was at 572, I think, milliseconds was this in this case, and the same for the throughput and so on. And we also see how Keptn calculated the score for that. For instance, we saw that the error rate has a higher weight of the as the other ones, so it has 50% of the score, and the other ones only have 25%. And for some reason. Okay, so from this demo and everything we saw until now, just a second. Now it works. What did we take away? So GitOps basically helps you delivering your software. So GitOps is not more and not less than a delivery mechanism. Data helps you gaining confidence in your deployment. So using the data you have in your observability solution, and whatever this is, if it is open source, if it is closed source or whatever, it helps you getting deployment stable. Keptn can help you in enhancing your GitOps workflows with data. So as you saw in the demonstration, you can hook in with Keptn. Keptn can do some evaluations, can trigger tests and whatever. And it can help you get enhancing, getting confidence. And yes, as I said before, validate your deployments customer-centric. So using SLOs, error patches, and so on. This is more, I think, more relevant than if your process uses 50% CPU, because sometimes you might have a low saturation on the host, but the application might also work perfectly fine. At some point, you might have not such a high load, but your application might not run perfectly. And in the end, continuously watch and remediate everything. So, yes, how could you get in touch with Keptn? At first, Keptn is working via Slack. So we have an own Slack workspace. Just subscribe, and if you want to talk to something regarding Keptn, regarding continuous delivery, and so on, I think you will find me here, so just ping me there. Furthermore, as I said, Keptn is a CNCF project. It is an open source project, and we, as every healthy project, we have monthly user groups and bi-weekly developer meetings. So you can also, they are all stated on the community page. Everything you saw here from the configurations and so on is stored in a Git repository. So at first, the integration of Argo CD, so the steps to get this integration working is stored in a Git repository. And also exactly this demonstration is stored in the Argo demo install repository. Yes, I think the same as for every open source project. Try it out, open issues, and yes, enhancements and improvements are always welcome. So, yes, this was it from my side. I think I was a bit too fast today. I hope you had as much fun as me, and yes, I'm open for questions now. I think it's, oops,
thank you. I think this is very much about, in reality, about providing good SLIs, right? Which is really valuable. So maybe you have many sources for SLI data. And you just showed a quite simple example. Can you also combine multiple sources for the same SLI? For example, security issues can come from container vulnerabilities, from dependency checks, from Docker configuration checks, from you name it. And these are all security issues. So is there a mechanism included to aggregate data from different SLI providers? Yeah.
So at the moment, Keptn only supports having one SLI provider at a time. But you can always combine. You can always have multiple SLIs for your vulnerabilities, and could weight them however you want. Oops.
So thank you for your talk. You mentioned that you had to do a couple of configuration steps, like adding some labels to your Argo resources. If we do have a bit of time, would you mind just providing us little like walkthroughs, like how does this configuration look like?
Yes, I can at least show you how the application looks like more in detail.
Mm-hmm.
Oops. So this was some of a typical configuration I did for my Argo for my demo here. What I added here was, and this was not very much, I added some labels here, such as the stage. So I know that I'm in my dev stage. I know that my service is called Potato Head, and that the Keptn project is called Argo Demo. So these were the things I needed for the ping pong, so for that I know where to ping back. And I also had to configure something in Argo itself, and I will try to get this open. Just a second. Just this one. And there is some kind of Argo configuration, and we have the notifications for Argo. And this does nothing more than sending a webhook to Keptn. I added the hostname of Keptn there, and we added some data to the cloud events we are talking to with Keptn. One of the hardest parts was that Keptn is building its own context. So what you saw in the Keptn bridge, that it has the pre-deployment, the deployment and post-deployment steps. They have to be they have to be put together somehow, and this is done via Keptn context or via correlation context ID. And the hardest part was exactly for this demo, where we also wanted to do some pre-deployment things. to get this through the Argo process. And we added this somewhere in the data of the Argo of the sync process, as far as I remember. Just a second. I know that we added this somewhere, but I can't find it now. But this gets added to the sync data, and after the sync has finished, this gets also passed over to Keptn again. And this was why you see everything in one sequence. But in the end, these two configurations in Argo CD, so setting up the notifications and setting up the labels on the application, are the only things you have to do in Argo CD.
All right, thank you.
Oh. Bisschen sportlich.
I know that this maybe in some environments it isn't allowed to be so, I call it dynamic, to go from a lower stage to production. Do you have like ideas how this can be implemented so that Keptn can say, for instance, this is now, it checked every box, now it's time for human review before it can reach like this, say, this final compliant cluster and so on?
Yes, so this is the same what we did here in the beginning of the process. So you can always do manual approvals. So for instance, yes, before you can say I want to get to the end and wait for an approval until some human says that everything is okay. I also had some use cases where I started to deploy in the dev stage. When the dev stage was working perfectly fine, I passed over to the hardening stage, deployed but did not release, and waited until someone approves for to switch the traffic.
Okay, this is really great, but going into existing environment and setups, of course, adoption has to happen somehow, and especially if we have extensive testing, which is built and existing already in various tools or pipelines. Can you integrate this here, or do you have to do all the testing, which is part of the post-deploy or validation process? Do you have to do it with Argo CD, or can you wire together whatever you have?
Yes, you can wire together whatever you want. So one thing where Keptn is pretty good is in integrating things. So you can take whatever tooling you want. So this is also one of the things we mention very often. We don't want to deploy by ourselves. There are many tools which can do it better than we. Furthermore, I think K6, JMeter, and so on are tools which are much better in testing as we will ever be for such things. And therefore, we are focusing on integrating such things. And this can be done via Keptn services, or we also have a generic service where you can add whatever CLI you want.
Thanks.
Any other questions? Okay, then if you have more questions, you find me outside. And thanks for having me here.